Hello students, I hope you all are fine. I am Dr. Tanmay Vishwash. I welcome you all in my channel Chemistry, the Mystery of Molecules. So today we will discuss a multiple choice question about bromination on this acetophenone. Okay, this phenyl methyl ketone. Okay, such type of question could be useful for BS exam like BSMS, B.Sc, M.Sc, IIT-JAM, CSIR-NET, GATE, BARC, BHU, etc. or exams equivalent to bachelor or master degree. Okay, so that's why I made this example. So as usual, I first request you please pause the video and try by yourself. It will help you for self-evaluation, and definitely after some time I will explain how the answer could be drawn, and at the end I shall explain within 30 seconds how can you solve such questions. Okay, please do it. I hope you have tried by yourself. Now it's time for myself to explain what is the answer and how the answer could be drawn. By the way, before going through details, I always suggest you, please read question carefully. I repeat, please read question carefully with a cool mind. Because if you try with a cool mind, there is a chance that some information, some difference could come out in your mind and you can observe it properly. Otherwise, there is a chance that you may know it, but since you haven't read properly, you have made the mistake. Additionally, there could be a lots of normal reaction as well as some exceptions available in the textbook. Generally, we read the normal reaction a lot and exceptions sometime, but it is generally observed teachers or examiner prefers exceptions. But it is highly desirable that you should know the general theory. Then only you will be able to answer or understand the exception. So this is actually exceptional properties. Why exceptional? See, the amount of AlCl3. This is pretty excess. Okay, compared to normal Friedel-Crafts alkylation. Okay, where for example in case of normal Friedel-Crafts alkylation, it is written that catalytic AlCl3, or you can say, means I am not sure, but based on my understanding I can say 0.1 equivalent or like that this AlCl3 stream. Okay, so this is even sometime in question you may find not AlCl3, Al2Cl6, and then the equivalence could be written 1.25 equivalent. Then also the question is exactly same. Means it is a smart strategy of an examiner to convert a known question into an unknown question, such that if you are a memorizing person, without understanding you are memorizing, then you will fall in trouble. Okay, so now generally this is the Friedel-Crafts, I say a halogenation. This is actually a halogenation reaction, better to say. I told the Friedel-Crafts acylation alkylation. It's not like that, it's my fault. So by mistake I have. So this is actually a halogenation reaction. Okay, so halogenation on aromatic nucleus. So actually this molecule is pretty interesting. See, it has a methyl group, aliphatic part. It has a aromatic part. Question where the reaction will go. So at this situation, just let me tell you, the answer of the problem, the answer of the question is this one. I know you will feel wiser. I am not agree with you such type of this rejection or misunderstanding or lack of agreement will occur. But don't worry, I'll explain it in such a way that after watching this video, you will be able to understand that wow, what an interesting example of topic you have learned today. Okay, so lots of interesting theories will be involved during the discussion. First of all, what is the nature of AlCl3? Generally, it is written that it is a Lewis acid, means that it has vacant orbital to accept an electron pair, or better to say it's a 6 electron species, this central aluminium atom, aluminium 3+. Okay. So it accepts some vacant electron, that's why it is called as Lewis acid. Fine. So what it does, this bromine AlCl3, what it does? If you react bromine with AlCl3, what it results? It converts AlCl3Br minus and bromine plus. I know sometimes such type of writing looks little odd. Aluminium, this thing, yes, because right now this is a 8 electron species. Okay, and this bromine is the electrophilic reagent, electrophile. So that's why this type of, such type of reaction should be considered as electrophilic halogenation. Okay, so electrophilic halogenation, this thing. So we have understood this Br plus is the main thing for our reaction. Okay, so if Br plus is the electrophile, then we have to find out where the nucleophile is present. See, if you check this molecule, there is a 2 chance. Generally, what such type of molecule can do? Such type of molecule, first of all, can form enol. Means this is enol, one option, and another option that they can participate in the reaction through the benzene nucleus. But there is an interesting thing. See, benzene nucleus is attached to an electron withdrawing carbonyl group. So this is less susceptible for any aromatic electrophilic substitution. I have already discussed about the basic concept of this aromatic electrophilic substitution in some previous videos. I suggest please visit if you have any doubt or difficulty in understanding. Fine. Now a question. Which is more electron rich, this or this? Actually this is. Why? Because see, in all, so this can push and this can react with any electrophile like this Br plus. Actually, please keep it in mind, this is not a free electrophile, it is an adapt. Okay? Okay, fine. So, actually better to say this, that I should not represent the reaction in this way. Instead of that, it is more logical. For your understanding, I have said, but it is better to present this way. It will attack and it will leave. And this Br minus will form adapt with AlCl3. Better not. Actually, this AlCl3 is the receiver, means host to stabilize the Br minus. Why? Because it is a 6 electron species, electron deficient, and bromine is electron rich. So if a deficient and rich come closer and form attack, both of them will stabilize. So that is the thing. So what is expected, that in this case means I am not going that much details. It should produce monohalogenation product. Okay. No further halogenation will occur. Please keep the information in mind. Acid condition, halogenation of ketone proceeds up to monohalogenation, and in under base catalyzed condition, trihalogenation. So we can consider mono but not di or tri. That or two options gone. Fine. This is one option. And another, it is less susceptible for AES, fine, but still if undergo any aromatic electrophilic substitution, where the substitution will occur, this meta position. So better to say this is meta orienting and this is symmetrical molecule, any one of them position is fine. So ultimately what is expected? So I am not going to any mechanism of aromatic electrophilic substitution. If you feel you have difficulty or you want to learn, please visit the playlist aromatic electrophilic and nucleophilic substitution. There you will find these videos. Fine. So two types of product possible. One is substitution at this phenyl, another is benzene. Now question, as I told, this is the product. Question, why not this? This is more logical. Additionally, if you think that in this case to achieve this conversion, first the aromatic electrophilic substitution happen on this nucleus, means you have to proceed in expense of a huge amount of energy, means aromaticity is a very high stabilization energy, and aromaticity will be disturbed because of the formation of sigma complex. What do I mean? The sigma complex is this one. See, this is the hydrogen and this is the bromine. Rest of the things are as it is. This, so this aromaticity is disturbed. That's not a very appreciable thing. If any other easy track happens, then it is that should happen. And see, this path is a little easier, but why this is? And that thing lies, that thing will get this very excess. So what this very excess part, why this very excess thing is so much controlling here. Now, then also a Lewis acid base interaction. How? See, initially if you react bromine and AlCl3, they will not form that. First of all, there need to someone who can consume bromide, sorry, Br plus. Then the addition left bromide will be consumed by AlCl3. Okay, so nothing. Now, we know that acid-base reactions are the fastest. Please keep this information in your mind. Acid-base reactions are fastest. Acid-base reactions are fastest. Okay. So what happens here? Lewis acid-base interaction happens. What do I mean by this statement, Lewis acid-base interaction? See, AlCl3 is Lewis acid. Is there any Lewis base present in the molecule? Yes. See, this is the lone pair of oxygen. So what happens? This AlCl3 and this benzene forms an adduct. What? This AlCl3. Formal negative charge goes on oxygen and formal positive charge on this. So now, a simple question comes. Okay, fine, this, but enolization, why enolization can't happen? Because this coordination will increase the acidity of this proton, we can accept, and then enolization will facile. But how this enolization happen? So if someone abstract one proton, then it goes, and in this way enolization happen. So actually some base is needed. Better to say this to this, or you may consider like this also. Okay, so it is coordinated with Al3+. So some base is essential for this proton abstraction. If you use catalytic amount of this AlCl3, this reaction became very easy. Why? Because catalytic means, for example, if you take 0.1 mole percent, so 0.1 equivalent 10 mole percent. If it is 0.1 equivalent, so means if you have 100 molecules in the reaction medium, only 10 molecules will form adduct with aluminium center. But 90 molecules are left, and those 90 molecules of these oxygen can act as a base to abstract this proton. Okay? And what happens if this molecule abstract the proton? Let me clean this part. So means, what do I mean? If you see, you need to understand this is more. Plus minus CH2H. This thing, another molecule of this acetophenone. Abstract this. So what it result? So one disease result I find. What about the fate of this? It became protonated species. Okay. This. So it is then activated. Some other molecule can abstract this proton. So in this way, enolization continues and catalyzed by catalytic amount of Al3+. Okay. But if you put excess Cl3, what you can expect? Every molecule, all molecule are this blocked. This reactor molecule is blocked. Then who will abstract as a base? No one is there to abstract as a base. And see, this is a pretty excess, 2.5 equivalent. Okay, so 1 equivalent consumed here. another left 1.5 equivalent. Now there is bromine. So when this is adduct is formed, for example here adduct is formed, then this ionization not possible at this site, so no reaction at this site, but this part is left, halogenation possible. And see, there was a bromine and 1.5 equivalent, 1 equivalent bromine, 1.5 equivalent AlCl3. Then this reaction can happen very easily. Okay, and the eliminated Br minus could be consumed, means Br minus eliminated 1 equivalent, there is 1.5 equivalent AlCl3, who can easily, very comfortably consume that Br minus. Reaction follows this pathway. I know this is a little ambiguous observation. That is the reason I have explained it so much thoroughly. Sometimes you may feel that, sir, why you are lengthening the problem unnecessarily? Because I believe everyone, it is essential for everyone to understand this thing. And if someone thinks that I know this, I don't need to spend, definitely please keep the button and go ahead. Okay, so this is beneficial. So that is the reason this. So what is the message? Message number 1, always read the question carefully. And second message, instead of that, if 2.5 equivalent AlCl3 0.1 equivalent, if we have taken this AlCl3, means catalytic, better to say catalytic, then what is the major product? Then the major product was just we have written this monohalogenation. Please be careful. In the exam, examiner can choose such type of question to confuse you. Okay, so this is the description, this is the overall description of this process. I know it's a very easy problem, but sometimes we make biggest mistake on easy problems. So that is the reason I remind you again, keep your mind cool, think logically and try. Now it's time to say what is the answer within 30 seconds. First of all, for that purpose, what we have to think? For that purpose, we need to consider few points. What are the few points? First of all, why excess? We need to remember the condition for halogenation. So why this is excess? Excess means there is something. So then this will be consumed, fine. For enolization, some proton abstraction reagent needed. No abstraction reagent. So enolized, so reaction will not happen this part. What is the left? Aromatic part. Now this is a withdrawing group, meta detecting. So if it is meta detecting, so either this or this are, since both it's a symmetrical molecule, no problem, and we have to find answer in the options. So there is one option where meta substitution there, so that is the answer. So not only 30 seconds, less than 30 seconds you can answer this question if you understand the logic properly. Okay, so this is the end of this discussion. Thank you everyone for your patience. If you really enjoyed it, please mention in the comment box. And I have a request, please subscribe my channel, Chemistry, the Mystery of Molecule, and please press the bell icon to get the notification of every single video I upload. Secondly, share these videos with your friends such that they can also enjoy the benefits of my effort. And most importantly, please like the video and make some good comments because it inspires me a lot. So thank you again. Stay happy, stay blessed. See you in my next video.